Hi, welcome back to part 2 of confidence intervals for slopes of least squares regression lines. One of the longest possible titles you could probably have for a video. I'm Aaron Hayes. I teach AP Stats. We're going through the Stats Medic curriculum here. We're on the second to last lesson. And so we're going to go ahead and formalize this. So we're going to give you all the basics and we'll go through a full problem for you. And then at that point, you should, with a little bit of practice, be ready to survive any of these questions that you'll see on the exam. Okay, so we'll jump over here. I'm going to zoom in a touch. Now this is one big idea. We're just going to go ahead and break this down kind of into thirds. And so the big idea is confidence interval for slopes, 4 steps as usual. The state, you're going to talk about beta being, and a capital B is fine. If you put a little italicized on it, that'd be even better. It's the true slope of the population, least squares regression line, for X in context and Y in context. And then you're also going to go through and give your confidence level on that. Okay, not terribly surprising. For the plan, you're going to go through that liner setup, and that is going to be very similar to what you saw So for the plan part, it's going to go through the section that we saw before. And so that is going to be a 1 sample t-test. It can be a 1 sample t-interval for slope, pardon me. And again, you're going to go through those 5 things that you need to have to go through and check to have it work. It needs to be linear, it needs to be independent, it needs to be normal. You need to have equal standard deviation. And again, for that, you just look at the residuals to see that it's about the same all the way across. And then it needs to be random. And if you, again, see the previous video for that if you want to hear some more about that. And then the last 2 parts is you're just going to do it and conclude. The do section here is going to be that you're going to take your point estimate plus or minus your margin of error. The point estimate is going to be your B value that you get from the mini tab or the computer printout. You're going to get your T star like we normally do. Remember, the degrees of freedom this time is going to be off 2, and then you're going to plug in that standard error for B. Again, also from the chart. And then you're just going to conclude like we've normally done. Okay? So down here, we've got a problem to run through. Too far. And so somebody wants to try to float across his yard holding balloons. And so he's trying to figure out how many balloons he'll need per pound. And so he selects a random sample of 20 rocks, figures out how many balloons he needs to tie to it, and goes from there. So notice here, we've got our data here. So here you've got your weight across the bottom and number of balloons at the top, X and Y, so that's already set for there. Here's your computer computer printout information here. So again, constant, this would be, if you're asked for the least squares regression line, it's going to be 6.211 plus 30.4126x. So this is going to be your slope. That's the one that we want. And notice here we've got our standard error as well. And so from there, and also just remember, slope is going to be the number of balloons you need per pound. So then from there, it's going to be pretty straightforward like what we just got done doing. So I guess I got to zoom out. So for the state part is this. We're going to do a 90% confidence interval. So for the state part, beta is the true slope of the population for the least squares regression line for the weight and balloons. And you also make sure you say which one's X, which one's Y. And you're going to do it at the 90% level. So for the plan, we're calling it obviously the 1 sample t interval for slope. And for your linear, we're going to go through and hit each of these individually. So hopefully this will reinforce what we're doing. So for the linear, we're going to look at the scatter plot. The scatter plot shows a fairly linear pattern. Okay, so if I go up here, yeah, that's pretty linear. The other thing you need to still do is look at the residual to make sure that it's not getting narrow or you don't see some bow in here that would seem to say it's quadratic or exponential. So we're good there. Independence, 20 is less than 10% of all rocks, which is self-explanatory. For normal, the residual plot shows no strong skew or outliers. So again, here's the residual plot here. You can also look over here at the dot plot because obviously no outliers there. Equal standard deviation. So the residual plot Similar variability, and this is what I was talking about. So if you look at here, they're all roughly, there's nothing really super surprising on that. There's not like a couple that are really big and a whole bunch that are small. So we're good there. And then for the randomness, we also have the random sample of 20 rocks. So we're okay on that. So then the last couple of things, the doing part here, point estimate, plus or minus margin of error. And that is a really bad M. I apologize for that. So B plus or minus T star times the standard error of B, 18 degrees of freedom. So then we go through and plug in all the information, the 30.426 and the 2.4106. And again, that's coming from up here. We plug it in and we go. And there's our confidence interval. So it looks like you're going to need about 30 balloons per pound. So the conclusion is we are 90% confidence that the interval from 26.87 to 33.95 balloons per pound captures the true slope of the least squares regression line for the number of balloons, which is our y value, and the number and the weight, which is our x value. So again, very similar to confidence intervals. There's the bell. I got to go do this again. But anyway, so if you can just double check here. If you want to subscribe, check over here. I will have videos in the, to other things over here. And then down below, we also have our review course that's coming out. So 3 weeks free and should be all ready to rock and roll. So I'm in the process, just got the first week done. So go ahead and we'll check from that. I'll talk to you later.